Vectors can mean different things depending on the school subject. I first heard about vectors in high school physics class and was told that a vector is something that has a magnitude as well as a direction. We use an arrow to denote the quantity as a vector. For example, velocity and force are vectors. When we walk somewhere, we have velocity. The magnitude is how quickly we're going, and the direction is the direction in which we are walking. A force is the amount, magnitude, of push or pull in a particular direction. The vectors I had in physics were only in 2 or 3 dimensions because, practically, the physical world can be analyzed in 2 or 3 dimensions, which we abbreviate as R2 or R3. The fancy R means the magnitude is a real number, and the superscript 2 or 3 means 2 or 3 dimensions, or components, in that vector. In math, vectors take a more generalized definition. I think of mathematical vectors as a list of numbers in a specific sequence. In math, we extend the concept of vectors to however many dimensions we want. We can also have R4, R5, or even Rn, however many components we want in a vector. This lesson is about how to do mathematical calculations with these vectors. Vector addition, subtraction, and scalar multiplication are quite simple because we do the operation to each component of the vector individually, component by component. We add and subtract component by component. With scalar multiplication, we multiply that scalar number to each component of the vector. A scalar quantity is just a number, and is not a list of numbers like a vector. Here's what I mean. We're given these vectors u, v, w, a, b, and c. We're going to do the following operations if they're defined. U plus v, adding component by component. 1 plus -2 is -1. -1 plus 0 is -1. 0 plus 3 is 3. 5 plus 1 is 6. W plus a. This is not defined because these vectors have mismatching dimensions. W has 4 components and A has 5 components, so if we were to add or subtract them together, we run out of numbers. 2 multiplied by, in brackets, W minus 3U. The idea of BEDMAS order of operations comes to mind. We have to do brackets and multiplication first, before we do addition and subtraction. Writing out these vectors fully, we have 2 multiplied by, in brackets, W is 2, 6, -7, 3, and then minus 3 of U, 1, -1, 0, 5. Multiplying the 3 into U, 3 times 1 is 3, 3 times -1 is -3, 3 times 0 is 0, 3 times 5 is 15. Notice that we're only multiplying that 3 into the vector. We didn't multiply the negative into the vector as well, so that negative is still there. Then we subtract these 2 vectors. 2 minus 3, -1. 6 minus a -3 becomes 6 plus 3, 9. -7 minus 0, -7. 3 minus 15, -12. Then multiply this result by 2. 2 times -1 is -2. 2 times 9, 18. 2 times -7, -14. 2 times -12, -24. Another way of solving this question is to think about distributing that 2 into the brackets. 2 multiplied by W, then 2 multiplied by -3U. We have 2W minus 6U. Multiplying 2 into W, we have 4, 12, -14, and 6. Then multiplying the 6 into U, we have 6, -6, 0, and 30. Notice that we only multiplied the 6 into U, we didn't multiply the negative as well, so the negative sign is still there. And simplify by subtracting these 2 vectors. -2, 18, -14, -24. A plus B, the sum multiplied by half, then subtract C. Putting in the vectors for A, B, and C. During the stuff in brackets, A plus B, we add component by component. 7, 1, -6, 5, and -8. That is multiplied by half, and then minus C just comes along. Multiplying the vector by half now, half of 7 is 7 over 2. Half of 1 is half. Half of -6 is -3. Half of 5 is 5 over 2. Half of -8 is -4. This vector subtract C. Since C has a bunch of weird, irrational numbers, we can't really simplify it. we just have to subtract component by component. 7/2 minus root 2, half minus e, -3 minus pi. 5/2 minus 1, we can simplify that. 5/2 minus 2/2 is 3/2. -4 minus 0 is -4. Another way of solving this question is to distribute that half into the brackets. We get half a plus half b minus c. We multiply half into each component of a, then we multiply half into each component of b. Then we add and subtract these vectors. 3/2 plus 2 minus root 2. 7/2 minus root 2. Half plus 0 minus e, half minus e. -2 plus -1 minus pi, -3 minus pi. 0 plus 5/2 minus 1 is 3/2. -5/2 plus -3/2 minus 0 is -4. In the first example, our vectors are column vectors. The components are arranged vertically in a column. In the second example, the vectors are row vectors. The components are arranged horizontally in a row. Whether we have column vectors or row vectors, the math is the same. We add, subtract, and scalar multiply component by component. We're given the vectors x, y, and z. Evaluate x minus y plus z. We do so component by component. X is 2, -3, 1, y is 0, 1, -4, and z is -2, -1, 0. Adding and subtracting component by component, 2 minus 0 plus -2 is 0. -3 minus 1 plus -1 is -5. 1 minus -4 plus 0 is 5. Next we have 3x plus 4y minus 2x minus z. Following the order of operations, we can deal with the stuff in brackets first, writing out the vectors x, y, and z. Then we scalar multiply that 3 into x. 3 times 2 is 6. 3 times -3, -9. 3 times 1, 3. And then multiply 4 into y. 4 times 0 is 0. 4 times 1, 4. 4 times -4, -16. Then we do the 2x. 2 times 2 is 4. 2 times -3, -6. 2 times 1, 2. Adding together 3x and 4y, 6 plus 0 is 6. -9 plus 4, -5. 3 plus -16, -13. And then subtracting 2x minus z. 4 minus a -2, 6. -6 minus -1, -5. 2 minus 0, 2. And then subtract these two results together. 6 minus 6 is 0. -5 minus -5 is 0. -13 minus 2, -15. Another way of solving this question is to multiply everything out. 3x plus 4y, that negative sign is then distributed into those brackets. Minus 2x minus a negative z. That double negative is a place where errors can occur. Then we can simplify by collecting like terms. 3x minus 2x is just 1x, and then 4y and z. Putting in these vectors, we can multiply the 4 into the y vector, but we can also do everything in one step, since it's relatively easy. 2 plus 4 times 0 plus -2 is 0. -3 plus 4 times 1 plus -1 is also 0. 1 plus 4 times -4 plus 0 is -15. So these two methods, whether we expand first or not, we get the same answer, 0, 0, -15.